Okay, friends, this is going to be chapter 1.8. Your textbook calls it new functions from old. I call it, and I think the rest of the world calls it, function compositions and transformations. Okay. So, first, this is in my notes. I'm not gonna write it out because it's a lot. So feel free to either write this out yourself, take a screenshot, copy it from my notes, or literally do whatever you want. Okay? Big picture, the reason why this is important to us is because one, you can talk about how you can transform functions by the M and the B, right? For linear functions, for everybody else, right? We've talked about using function transformations from this guy, from the parent form, this guy. We've actually done it for all of these, right? Um, for this guy, right? This form is less useful I guess. But this does tell you like the end behavior with that and the exponent. If this sounds new to you, you're in the wrong chapter. Go to chapter 1.9 first and then come back to me. Okay. Um, it's also more useful in factored form, again, for graphing purposes. And this is a special form, a specific form of this guy, right? It's a quadratic. This is your vertex. It's in vertex form. So h comma k is your vertex. A is your, again, it's your leading coefficient, but it's also like the stretch and shrink, so you can tell whether it does this or like this or whatever. Um, but the most important part is that end behavior is important. If you can eyeball what a function more or less looks like by the ends, as well as like maybe some stuff in the middle, especially with like the factor form of this guy, right? Um, you can fact check your calculus and you can graph things a lot faster and prevent weird mistakes. All right. Um, cool. Yeah, that's it for this. Okay. The important part of this lecture, other than that baloney, is function compositions. Okay. So this is going to be our definition 19. Function compositions. Okay. I'll show you what that looks like. Big picture, we're going to say let f of x be one function and g of x be another. Two ways to write this. F of g of x. I guess if you want, you can write x in white. Alternatively, you can write it as f of g, the whole thing of x, right? I prefer this form. It's more intuitive. Um, yeah, that's it. It's just more intuitive. Um, yeah, I'll cut that out. All it means is you take g of x and replace every x in f of x with g of x. Okay. And I'll explain why this is important in a bit. So, for example, let's say um, f of x is equal to negative 3x squared plus 2x minus 1, right? Then, and g of x is equal to sine of x, right? Then f of g of x, or should have done that in blue, there you go, is equal to negative 3. Oh, look, there's an x squared. So parentheses, right? Because that's where the x goes, right? Squared. And what goes inside? G of x. Plus 2. Oh, look, there's an x there. And what goes in there? G of x minus 1. Wait, but we know what g of x is. It's equal to sine, right? So this is going to be -3 parentheses sine of x, the whole thing squared, plus 2. Oh, look, sine of x minus 1. Please, 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 pretty please. Use your parentheses. Okay. I don't want to see like negative, um, actually, this isn't a great example. I'll show you in a second. Okay. Okay. Another example, and this is important, this is very, very important, is let's say you have f of x is equal to, I don't know, x squared. Make it easy. G of x is equal to cosine of x plus 8. F of g of x, I'll make you guys get used to both notations, okay? Is not, okay, not equal to cosine squared x plus 8. Bad. Don't do that. Parentheses are important. It is equal to cosine of x plus 8, the whole thing, squared. Why do we care about function compositions? Am I recording? Yes, I am. Okay. Big picture. How do compositions behave? Okay, so let's say we're taking, let's do that in blue actually. F of g of x, right? Okay, what it does is it takes g and it sends it to, this means maps to, g of x, whatever that value is, right? Ooh. And then it takes whatever this value is, right? And it maps it to f of g of x, okay? Oh, rats. Right? So, for example, let's say f of x is equal to, I don't know, 7x plus 1, and g of x is equal to x squared, right? F of g of 9 is going to go as f of g, f of, what is g of 9? G of 9 is equal to 81. 81. What is f of 81? F of 81 is 7 times 81 plus 1. I don't really care what the value is. You guys just need to know how these things move. Okay, I think that's fair. All right. The reason why this is particularly interesting is because what it does is it takes intuitively, the domain of G, right? Whatever, and it sends it to the image, or as what we call it, the range, not codomain, range of G, which now is going to behave as the new domain of F. And then you map it to the range of f, right? So what it does is it takes this guy, it sends it to this guy, and it sends it to that guy. Okay? Um, Obviously, right? Sometimes not everything will map nicely. So, for example, let's say g of x is equal to x squared, right? Um, and f of x is root x, right? So the domain of x, oh, sorry, of g is all real numbers, right? And it's going to send it to the range. The range of g is going to be, only non-negatives. So it's going to send it to 0 to infinity. And then you're going to square root it, right? This is the new domain of f of g of x, technically, right? Let me fix that. Of f of g. And then you're going to take this and you're going to shoot it over to, luckily, this is going to be 0 to infinity. Range of f g x, right? And that's like fine. That's cool, right? That's kind of cute. It's kind of cute, right? Um, until it's not. When is it not cute? It's not cute when you have, let's see, the domain, let's say g of x is equal to negative x squared, and f of x is equal to root x. Uh-oh. The domain of g is all real numbers, right? Negative infinity to positive infinity. And your range of g is going to shoot you into negative infinity to 0 inclusive, right? It's just a parabola. It does like boop, right? And then you're going to shoot that over to, you're going to run it through f of x, except you can't run negative infinity to 0, exclusive of 0, right? You can't exactly do that because that is out of the domain of f. So the image of this composition is, or the range is another way to say it, is just 0. Okay, so just be very careful of this. Um, yeah, that's all. Exciting stuff in it. That's all. All right, thank you, friends.